To calibrate my flow meters, first I'll enable flow meter 1. I'll also turn off the boiler element, which means I'm not having to handle hot water during the calibration process. Scrolling down, here are the pulses per mil value for each flow meter. I'll use the manufacturer's recommended pulses per mil value as a starting point for my calibration. Scrolling down further, I'll set my shot target at 100 mils, and now I'll upload the code. Once a flow meter is enabled, the display updates with a water counter. In order to correctly calibrate the first flow meter, I'll place a container to catch the water from the group head. For dual flow meter configurations, I'll also need to place a second container to capture the water from the return line. With espresso mode on, I let the pump run until it automatically shuts off. Before returning the brew lever, I noted down the displayed water volume was 102.6 mils. Using a set of scales, I measured the water from both containers, which comes out to 121.9 mils. To calculate the new pulses per mil value, enter the display water volume, then divide that number by the actual amount of water dispensed. Then multiply this new value by your current pulses per mil value. In my case, I'm using a value of 5. And this is my new pulses per mil value. I recommend rounding this number to the nearest decimal place, so this long number will be rounded to 4.2. I update the code with my new value and send it to the Arduino. Now I reset the containers and pull another shot. This time the displayed value is 103.8. Now wouldn't it be great if I nailed calibration on the first try? Yeah, that was never going to happen. But we're pretty close. From here I didn't bother recalculating the value. Instead, I just increased the value in small increments. And ultimately I found a pulses per mil value of 4.3 proved accurate. For single flow meter configurations, calibration would be complete at this point. For dual flow meter configurations, I can move on to calibrating the second flow meter that's on the return line. I enabled the second flow meter on my setup tab and entered 100 pulses per mil as a starting value. Lastly, I enabled flow meter 2 test. Enabling this feature means the Arduino ignores the first flow meter we just calibrated. This allows me to evaluate each flow meter independently. Since the return line flow meter is much smaller and thus flows less water, I'll reduce my shot target to 50 mils and upload the code. To increase the water flow through the return line, I'm using a blind basket in the group head. Just like before, I noted down the displayed water volume and then weighed the water. Then it's simply a matter of dividing the displayed water amount by the actual amount of water and then multiplying that by my current pulses per mil value. My new pulses per mil value is 123.6. After uploading it to the Arduino, I was delighted to say this time that the calibration was successful on the first try. With both flow meters calibrated, I disabled flow meter 2 test and set my shot target for 60 mils. Now I placed a single container under the group head and pulled a shot. The displayed amount was 63 mils of water, and the weighed amount was only half a milliliter more, which is better than the 5% accuracy claimed by the flow meter's manufacturer, so I'll take that as a win. Now I'd love to say that this was the end of calibrating the flow meters. However, I did have to pull some shots and tweak values slightly to dial in the accuracy. Water flow dynamics is rather complex, and I found that using a blind basket to increase the flow on the return line meant the flow meter spins much faster compared to pulling a shot with coffee grounds in a basket, which ultimately threw off my calibration. Really, if I was doing this again, I would seriously consider purchasing a single high pressure flow meter, since it would have made calibration much quicker and easier. Despite this, the end result has proven to be sufficiently accurate, so overall I'm happy with the end result.